So let us now talk about density or mass function. So the first example is random variable takes on just two values, 1 and 5, and the associated probability with these random variables is half. So we draw it on the graph. So the probability is right here. This is between 0 and 1, and the random variable is right here. It just takes on two values, 1 and 5. So at 1, the probability is half, and at 5, the probability is half. So this is the simple density function. Now we want to make it a distribution function. The distribution function just cumulates this density. So the distribution function associated with the random variable x is given as f of small x. The small x is nothing but a real number. This is equal to probability of this random variable taking on values less than or equal to small x. Now this is nothing but the technical condition. So the technical condition was omega such that x of omega is less than equal to small x, where small x is a real number and this omega is nothing but part of the sample space. So we are basically applying probability to all these omegas which lie in the sample space. So this was the technical condition which we discussed in the definition of the random variable. So this is a cumulative condition. You are just talking about less than equal to some real number. So let us see this in an example. So we are just going to focus on this first example. So if x is less than 1, this distribution function is 0. So notice the density function. Before 1, nothing. There is no dot anywhere before 1 or after 5 or between 1 and 5. So before 1, everything is 0. So this is cumulative. So before 1, everything is 0. So this is the distribution function. And this you can write as density function small f, this capital F. So at 1, there is a jump by half, because at 1 you have half. So there is a jump by half. Now since this is cumulative, this half remains like this till you reach 5. So between 1 and 5 you do not add anything in the probability. You see the probability here is just 0 between 1 and 5. So the probability is half at 1 and probability is half at 5. Between 1 and 5, before 1, after 5 it is 0. So this just remains half here in the corresponding distribution function. At 5, again there is a jump. So there is this probability half associated with 5. So you again add half here. So this half you take and you add here. And this becomes the distribution function. And after 5, you cannot add anything to it because it is 0 right here. So again, so before 1, everything is 0. You're just copying from here. At 1, there is a jump by half. So this half you add to 0 here. Then 1 to 5, it remains constant because you're not adding anything between 1 and 5. At 5, again, you have to add another dot, this jump half here, and you get this. Now let us consider another example. So again, you have another random variable capital Y. When it takes value 2, the probability associated is 1 by 4. When it takes value 1, probability associated is 2 by 4. When it takes value 0, probability associated is 1 by 4. So let us draw this. So at 0, you have 1 by 4. At 1, you have 2 by 4. 2 by 4 is half or 0.5, which comes right here. And at 2, again, you have 1 by 4. So we have drawn this here. Now we draw the distribution function. Now before 0, nothing happens because you cannot add anything. So there is nothing before 0. So before 0, everything is 0. Between 0 and 1, everything is 0. There is a jump at 1. Between 1 and 2, everything is 0. After 2, everything is 0. So there are only 3 points, 0, 1 and 2, where there is some probability associated with it. And in distribution function, we are going to take this probability as cumulative. So before 0, everything is 0. At 0, there is a jump of 1 by 4. So you have copied this right here. So from 0 to 1, you do not add anything to it. So from 0 to 1, it remains at 1 by 4. At 1, there is a jump of half. So there is a jump here of half. So you got to add half here. So if you add half to 1 by 4, you get 3 by 4. So 3 by 4 will take you here. So this is 3 by 4. So 3 by 4 will take you here because this is the jump of 1/2 you have added from here to here. Now this will remain like this till it reaches 2. At 2 again there is a jump of 1 by 4. So you add this 1 by 4 here. You add 1 by 4 to 3 by 4. You get 1. So you add 1 by 4 from here to here. And you get this. And after 2 there is no further jumps. Obviously probability of 1 by 4 plus half plus 1 by 4 is 1. So obviously since probabilities should add up to 1, we cannot add any more probabilities. So this is the distribution function. So notice the difference. So this is the density function or mass function, and this is the distribution function. So distribution function is cumulative, and distribution function lies between 0 and 1. So these two should be clear. Now let us focus on a very important property of the distribution function, and that property is the right continuity. So what does this even mean? So notice that at, say, we are focusing on this distribution function f subscript x. So at 5 the function jumps. So there is a hole here and it takes value 1 at 5. So there is a jump here. Similarly at this distribution function at 1 there is a hole here. The function takes the value 3 by 4. So at 1 function does not take the value 1 by 4. It takes the value 3 by 4. At 2 again there is a jump. So there is a hole here. Function does not take the value 3 by 4. Function takes on the value 1. So again at 1 the function takes on value 3 by 4. So I make it solid. Then it takes value 3 by 4 all the way till very close to 2. At 2 the function again jumps and it takes value 1, and then it takes value 1 all the way. So notice how there is a hole here. So right continuity means that if you go from the right side, so if I go from the right side, I do not encounter a hole. I get the value of the function. Similarly, if I go from here, I do not encounter a hole. I get the value of the function. So this is called right continuous. Now obviously the function is not left continuous, because if you try to go from the left side, say if you try to go like this, you encounter a hole. So you do not reach the value of the function if you try to go from the left side, but you reach the value of the function when you try to go from the right side, because of jumps like this and holes like this. So you have to keep this in mind. This is very important to understand that the distribution function is right continuous. So again you have a hole here and you have a solid point here. So at 5 the function takes on value 1. So between 1 and 5 the function takes on value half. But as soon as the function reaches 5, as soon as you reach number 5, it jumps. But if you go from the right side towards this point, you get a solid point. If you try to go from the left side, you get a hole. Since you get a solid point from the right side, it is called right continuous.